Today we're going to take a look at another kind of a loop. We've already taken some time and looked at the while loop, which allowed us to create a loop based on an exit condition where we evaluated some particular condition as to whether it was true or false. The for loop is a little bit different than that. The for loop uses similar scenarios in the sense that it still uses some relational and logical operators, but the difference is that with a for loop we simply are sequencing through a series of values, pretty much a fixed series of values, looking to execute a certain block of code over and over again a certain number of times. Now the sequence, most of the time it's some progression of numbers, but it can also be for a given string, or for every line in a file, for instance, is another example, or for every object in a list. And these are applicable to some of our homework assignments. For instance, when we read through the quiz.txt file, we're using a for loop to do that, and we're going through it, and for each line we're reading it in and assigning it to a list. And then you can also use the for loop to go through the list itself and look at the individual objects in the list and do something with them. So let's take a look here at some examples of how they do this. The for loop has the following syntax. It has for a variable in some particular sequence. So the for and the in are the fixed parts of the syntax, and the variables that you put in there and this type of a sequence will depend on what you're trying to do. And then of course it just executes whatever the block of statements is below that. And also don't forget that the Python syntax here, you have to have that semicolon at the end of the loop statement, which allows it to indent down, and then you have to break the indentation when you're finished with whatever the for loop block of statements is. So let's take a look at another element that can be used with the for loop. It's called the range function. This makes it very simple to identify a certain sequence of values that you want the loop to step through. In the first example here, the range of 3 to 10 is going to use the values 3, 4, 5, 6, 7, 8, and 9 to execute through the loop. Notice that the last value, 10, is not actually executed inside the loop. That's more of an exit condition. So you need to keep that in mind when you're setting up a range, is that last value is typically one more than what you really want. And of course you can use the same negative to positive ranges. It'll step through those no problem. So here's an example for I being the variable that's going to get counted. For I in the range of 2 to 6, do this: print I and then print I times I. So each time it rolls through the loop, when it starts off, the first value through the loop is going to be the beginning of the range. So I will be equal to 2. So the first run through, you see that I is equal to 2, and I times I, 2 times 2 is equal to 4. Jumps right back to the top of the loop, automatically increments I to be 3, and rolls through the loop again. And it just keeps rolling through the loop until the next, last time it prints 5 here, it comes up to the top of the loop, automatically increments to 6, sees that 6 is the exit condition, and then it terminates the loop. Here's another example. Display a table showing the population in each year until 2018. And of course we're assuming here there's a population, back up there, a population increase by 3%. So we start off, we set our pop variable equal to 300,000. We set up some print formatting statements here. If you recall, this particular dot format scenario is what is being specified here. So the first element, 0, which is year. Here's the first, or the second element is population. This one is going to be a field width of 10. So that's just what you see down here, field width of 10. And there's nothing else further that's specified on this one. So here's your for loop. For variable that we specified called year in a range of 2014 to 2019. Print, and again, here's another format statement. The population equal to the population plus 3% times the population. So this statement is one of the more concise ones. Simply is taking the existing population. Remember, we read from right to left as we're doing these assignment statements. So the population starts out at 300,000. We multiply it times 0.03, then we add it to the existing population, which is implied by the statement, and then we assign the result to population. So as we roll through, we're going to see the first year it's going to print 2014, and the population actually printed up top first. The first year is printed out here, and then we increment the values as we roll back to the top, come back through the loop, print out the next year, which will be increased by 3%, and so on until we get to the exit condition of 2019. Here's the simple flow chart of that previous example. As you might expect, we start, set up our initial variable. The loop decision statement essentially looks like this. It says, is there an item in the range that has not yet been assigned to the variable year? If that's true, then we assign the next sequence to the variable year. We do what's in the code and we roll back to the top. I don't personally find these flowcharts particularly useful for trying to sort out a for loop, but this is basically what it would look like. So the step values, there is a possibility of having a third element in a range argument here, the first two arguments being the beginning and ending of a sequence, but the third element in the argument could be a specific step that you wanted to have the sequence generate. So if instead of stepping by an automatic default of 1, we could specify 2. This could be useful for working out odd and even number sequences. We could increment by 5s, or we could go by 4s, or whatever happens to be useful to what we're trying to do. So that third possible argument is the step value. Here's another example using a savings deposit scenario where you calculate the balance after every 3 months. You get your initial input, prompting from the user, and then you calculate the rate of interest. But the for loop, which is what we're interested in down here, says for I in the range of 3 to 13, step by 3. So this is a way of looking at a year done by quarters, a quarterly report if you want. So the first item is going to be the end of the first quarter, and the last item is going to be the end of the year. So then we will execute the print statement based on this particular formatting. Okay, remember the 0 element, field width of 2, the first element, left justified, field width of 15. We want commas, and we want 2 decimal points because it's a floating number. Okay, and then here's the format. So we're printing I. I is the first element. Initial deposit is the second. Let me go down and see the rest of this. Here's the rest of it. Here's how it would print out. And you see it loops through and shows us at the end of each quarter what the balance would be in the savings account. Not a particularly efficient savings account there. Need to have more interest on your savings. All right, here's a negative step value. Instead of the positive step value, you can have go backwards, which makes sense. I mean, there's no reason you couldn't go backwards. You can also nest for loops. Just like we could with while loops, you can nest for loops inside of other for loops, or you can mix them all up. It doesn't matter. You can have for loops inside of while loops or vice versa. The only particular thing you have to watch out for is make sure that the second loop is completely contained inside the first loop. You can't have one loop trying to end outside of its parent. That doesn't work. You'll get error when you try and do that. And then also they have to have a different loop variable. You can't have for I equal blah 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 and then in your nested loop also have for I, because those variables have to be different. So you'd have to have for I equals and for j, different variables like that. Here's an example of a nested for loop that has for m in the range of 1 to 6 and for n in the range of 1 to 6. Print out a multiplication table. So good example, the first variable will stay the same while this one increments. That allows us to print out the multipliers of 1 and then 2 and so on and so forth. So nested loops can be pretty handy depending on what you're trying to do. Here's another example that just prints a kind of an increasing triangle of asterisks for I in the range of some particular number of rows that we input up here, and then for j in the range of I plus 1. So we're just going to add 1 each time. This print statement allows us to remember the end condition here is blank, so we won't get a new line until we execute this. Here's one that reverses the letters in a word. This one is surprisingly concise and simple and a little hard to wrap your head around when you first look at it. But if, let's say we input a word, stick it in here, we initialize a reversed word variable to be null or empty, well, not empty, but a blank value. Then we say for character in word, reverse word equals the character plus the reversed word. You have to think about that a little bit, but it does exactly what the logic says it will do, in the sense that it takes the initial character, adds it to the reversed word, and assigns it over here. So the first time through, the first character is going to get assigned. And the second time through, it just adds to itself. So it's a little bit tricky to look at this and understand why it works, but if you test it, you'll see that it does, in fact. This is more pertinent to one of our homework assignments of what we're going to do with the quiz, looping through items of a list or a tuple. Now in this particular case, it's a fixed tuple. Remember, the tuples are the ones with the parens around the outside. These are immutable objects, so you cannot change them, which not necessarily, well, it would be applicable to our quiz because we're not going to change the data in the quiz. But we don't want to manually construct all the information inside of our quiz either. We need to be able to read that in. But take a look at what they're doing here. They're setting up a tuple called months, and then they're saying for month in month. That means that this is a new variable. This is your counter variable. It's going to increment. So for each of these months that's in the tuple month, if there is an R in month, and we're using the dot lower to force it to lowercase, then print that month. So it'll simply loop through here for each month in months. In other words, it'll go through the entire tuple one at a time until it's done. So very simple, short, concise syntax to loop through this tuple and manipulate the data, or act upon the data, I should say. You're not actually manipulating it. And of course it prints out those months that have an R in them. Here's the same thing, but a little bit different in the sense that it's using only the first three letters. So it's replacing the name of each month with its three-letter abbreviation. Now notice that this time, since we're actually manipulating the data inside of here, it's no longer a tuple, it's a list. And then we're referring to specific elements of the list by the index value here, I. So this is going to be useful in type of a strategy in working through the quiz data. So here we say, we have our months already predefined for I in the range of the length of months. So the length of months tells you how many elements there are in here. So that tells us how many times we're going to loop through it. And then we're saying that let's read from right to left. This is an assignment statement here. Months I, which initially will be January, the first three characters, 0, 1, and 2, assign those back to months I. So when we're done, months I just has January in it. And then it does that for each one of them. That's how we get the first three letters. So this practice of using or addressing a specific index value of the list, you can do this with your quiz data. So if this was quiz data and you were interested in, printing out or doing something with the 4 multiple choice answers, this value down here would change. It would be quiz data, perhaps the first one would be, let's see, 0 is the correct answer, 1 is the question itself. So index 2, 3, 4, and 5 would represent the actual questions that you were going to, or possible answers that you would use for the question. Here's another example using a deck of cards, creating a list that has 52 cards. So we start off with a list of the possible values that are in the rank of the cards, and another list that are the possible values for the suits. Then we establish an empty list called deck of cards that's going to hold all of the values as we loop through. So for the rank in ranks and for suit in suits, so here's a nested loop, but pay attention to this part. This is important here. The deck of cards dot append some value. Okay, so this is how we build this new list up here. For each time we're going through the loop, we're appending a new element to this list. So you can see rank and suit are obviously part of this. And so that's how the deck of cards will get built. And you can see over to the right here where they ran it. So this would, first value coming into this would be 2 of spades. 2 of spades. This text gets assigned to deck of cards element 0. Another flow chart that talks about looping through a list or a tuple. And of course, we've already experimented a little bit with this in our quiz.txt where we opened the file, and we read the file in, but now we're going to actually look at the, the for loop that does the work here. We kind of just ignored it the first time we saw it and you just used it. But here we're opening a file. This value in file can be anything. It doesn't have to be this. But we're going to open the file name, say quiz.txt in read mode. For each line in file, we're going to do some code, and then we're going to close it. So this is how we can take data off of a file and process it. So initially it just reads it, but let's take a look at the example here. Here's one that goes through a series of text file, elements in a text file that has the names of the U.S. presidents. Just that's all it's in. It's just the first and last name of the president. So the first name, we're going to try and match and figure this out, which presidents have a certain first name. So we'll input a first name. We're going to set up a Boolean variable here of the found flag. We're going to set it to be false. We're going to open our file, uspresidents.txt. For each line in the file, we're making this conditional statement. If the line starts with the first name that we input up here, plus a space, because that's how we know that it's a full first name. You wouldn't want two names that happen to start with first characters to match. So that's what the purpose of the space is here. And then we're going to strip the new line off the end, and we're going to set the found flag equal to true. So we're going to roll through each line in the file and print it out. And notice that assuming that we found at least one match, then this will get set to true. If we loop through the whole file but we don't get any matches, then found flag is still going to be false. So when we close the file and we then make the statement, if not found flag, then we can print that no president had that first name that we input. So this is some reverse logic here. If not found flag, well, we set up found flag to be false, and we were going to set it to true if something was found. Now normally we would have a tendency to say if found flag is true, but in this case we can reverse the logic with the not statement. So if you put in the first name of John, these are the hits that you would get through the file, the first presidents that had a first name of John. Okay, remember in the while loop we had a thing called a continue statement. There were opportunities to abort the code that we were working through and go back to the top of the list or the top of the loop and start over again with a continue statement. The for loop has a similar thing called a pass statement. So there are times when you might want to just skip and not do anything. So they call it a do nothing statement or a placeholder statement. In some code, different languages, it'll be called a no op, a no operation. But in this case, pass, this doesn't do anything, and it lets you loop through the cycle. So here's a kind of a very simplistic display of what that does. This program displays only the last line of a file. So what it does is it skips through this loop. It never does anything. It just skips all the way through the loop. And when it gets to the end, obviously the last line that would have been read is the last line, and it prints that out. But it illustrates the concept of using the pass. Here's an example of populating a list with the contents of a text file. Now this is also relevant to our quiz data that we're trying to do. We're going to set up an empty list here called data list. We're going to open our file, and for each line in the file we're going to append that line to data list. So we're building a list of the individual lines in the file, and we've done that with quiz.txt. This is a little bit more efficient way. I wouldn't worry too much about this right now. As you get more experienced in writing code, oftentimes you might look for ways to be a little bit more efficient and more concise in your code. But until you get to that stage, I wouldn't worry too much about it. Just know that you can sometimes shorten up your code, make it a little bit more efficient. And that's the end of our for loop section. We'll be able to apply some of this in our programming assignments, and we'll get some homework posted and let you get a little bit of practice with that.